Welcome to your lesson on ellipses. This is actually in two parts. One part will handle the mechanics, but the other part is a visual. So I'd really encourage you to take a look at that visual aspect of ellipses. So let's get into the meat of this. What is an ellipse and how is it different than a circle? And you see, by the way, look at this great picture. All these ellipses being shown here on this page. Well, an ellipse by definition set of all points in a plane, and in a plane basically means that it is two-dimensional, it's flat, whose distance from two fixed points, point F1 and F2, add up to a constant. So basically, here's what an ellipse is. If you took a piece of paper and you put a nail in one point, F1, F stands for the focus, and a nail in a second point, F2, and again, this would be the second focus, and you tied a string around both nails and you pulled that string tight, then if you took your pencil and pulled it as hard as you could off here to the side, you would make the shape of an ellipse as you quote unquote circled around those 2 points. The constant distance between this focus and a point on the ellipse and this focus and a point on the ellipse will always add up to the same thing. In this case, that length is the length of the string. And we happen to call the distance from one of the foci being the plural of focus, to a point on the ellipse, A, and from another focus to a point on the ellipse, B. So that's an ellipse, and you read about that last night in your reading where you kind of talked about how A and B are related to the foci. And that's a nice little mathematical explanation of some ideas we're going to be using later on in this video. So let's get into the purpose. Why study ellipses? Well, ellipses are really cool because, let me go back here, one of the magical properties of an ellipse is anytime you have a, let me get a picture here, anytime you come from one of the two foci and you shoot some particle off towards the ellipse, it's going to hit the side of the ellipse and it's going to bounce directly into the other focus. Anytime. So anytime you're standing here and you leave one of the foci and you draw, look at that guy just spinning. You shoot a particle off from one of the foci, it's going to hit the wall of the ellipse and bounce directly to the other focus. Now would be a good time to actually pause this video, go back into Google Classroom, and look at how I constructed an ellipse. And then also in that same video, I go to an actual ellipse and I show you how all the particles that leave one of the two foci and bounce off the wall of the ellipse will converge on the other focus. It's pretty cool and it's worth pausing and watching. Hey, when you come back, here's one of the purposes that we have, reasons why we have an ellipse. One of the ways we handle kidney stones is kidney stones are these calcium deposits that develop in people's kidneys. And they're pretty large and they're too large to pass through the urinary tract and outside the body. And one of the treatments for a kidney stone is called ellipsotripsy, in which you have basically part of an ellipse right here, and you insert into that ellipse an electrode, and that's going to fire off a series of electric shocks, and the person is submerged in water, and they are lined up so the kidney stone is at one of the two foci for this elliptical shape. And so what happens is you fire off a series of these electric shocks. They hit the wall of the ellipse and they come in here, and what happens because it's an ellipse is they all converge at the same time at the same point. Now one of these shocks is not really going to affect the body that much, but when they all converge at one point, it's enough to explode that kidney stone into smaller pieces that then can pass through the urinary tract and outside the body. It's a really cool real life situation in which we use ellipses. Now, let's get into some terminology behind ellipses and see how they're done. The two types of ellipses that we're going to concern ourselves with are the ellipses that are horizontally based and the ellipses that are vertically based. We're not going to really worry about the ellipses that are tilted in any way. And so in this ellipse, you have this black point right here, which is the center of the ellipse, much like the center of a circle. Now, these two red points here, those are the foci. And notice that the foci are equally spaced from the center, and they're equally spaced from the extreme sides of the ellipse. And those extreme points out here and here are called the vertices. Now, these vertices, they are the endpoints of what we call this major axis. The major axis is the longest actually, chord, if you will, of an ellipse. It goes from side to side and it passes through the center. And then the shortest distance passing through the center is called the minor axis. And so you can see for horizontal and vertical ellipses, we have these names. And I'd like you to know the names because I'm going to use them a lot in this video. Okay, so let's take a look at some important ideas. We call the distance from the very center of the ellipse along the major axis to a vertex, that's called A. And this is part of what you read about in your book. We call this distance from the center along half of the minor axis, we call that B. And then we call the distance from the center to a focus, either focus, it doesn't matter, that's called C. And it just so happens that these three items are related through the Pythagorean theorem, and this is what you read about, and it turns out that C squared equals A squared minus B squared. Or you could say B squared plus C squared equals A squared. But I like to think about things in terms of C. So this is a very important formula. We're going to come to it over and over and over again in the next couple of pages. But first, let's make sure we understand that the major axis here, the major axis is 2A in length. Remember, A goes from the center to one of the vertices. So the whole thing is 2A. And the minor axis then, that would be 2B. And so maybe I should come down here. The minor axis, where are you? Somewhere down here. 2B. Now, let's go ahead and take a look at the math behind ellipses and see what's going on. So we have horizontal ellipses and we have vertical ellipses. And the center we call HK, just like we did for a circle. And so you can see here that in our equation for an ellipse, we have the quantity of x minus h squared plus the quantity of y minus k squared equals 1. And that alone, just forget this a and this b, that alone is the equation of a circle. But the difference between an ellipse and a circle is an ellipse is stretched more in one direction than it is in another. Now in a circle, a and b would be the same thing. They'd be the same number because they'd be stretched equally. Well, what happens in an ellipse, a horizontal ellipse, is a is bigger than b. And in a vertical ellipse, notice how a is under the y. A is bigger than b. So one way to tell the difference between whether you're dealing with a horizontal ellipse or a vertical ellipse is which variable has the larger number underneath it. Remember, a is always half the major axis. And so if a is under the x, it's horizontal. If a is under the y, it's vertical. So if you look down here at this ellipse, you can tell in its ellipse. See how we have x squared plus y squared equals 1, and the numbers under the x and the y are two different numbers. Since the bigger number is under the x, we would say this ellipse has to be horizontal. And I like to think of it as this number under the x, it's pulling it, it's stretching that ellipse further horizontally than it is vertically. Okay, so let's take a look and see how we can do some of the problems you're going to be faced with tonight. Okay, so this is where you're going to be pausing the video a lot and then coming back to see how you did. So why don't you pause the video and write down all the information you need for this ellipse right here. Hey, welcome back. So here we go. Let's see what we're up against. I need to get all this information for this ellipse right here. Let me just slide this up a little bit so we have some space to work with. Oh, don't look at that yet. Okay, let's knock out the easy stuff here. The center. Just like a circle, we know that this 3 and this -1 are responsible for the center. I already drew a vertical ellipse because the 9 is bigger than the 4. So since 9 is bigger than 4 and 9 is under the y, I know that that's going to be a vertical ellipse. So center, 3, -1, and I put it in my picture. Now, something else that I think is important is remember this number is a squared. And so that means that this is 3 squared. And this number here is b squared, so that's 2 squared. And remember, the length of the major axis, the whole thing is 2a. So just part of it is going to be 3. And the minor axis, part of it, half of it, is going to be 2. So what are the coordinates of the vertices? Well, the vertices are at the ends of the major axis. So if I'm standing right here in the middle at the point 3, -1, and I go up 3, that affects my y. If I go down 3, that affects my y. And it gives me these two coordinates that are the endpoints of my vertices. And by the way, we could also find the endpoints of my minor axis, although I didn't ask for it. But if you're standing at the center and you go left 2 versus going right 2, you have two different results that affect the x's. By the way, you could also see that my minor axis has a length of 4. My major axis has a length of 6. All we have to do now are find the coordinates of the foci. Well, remember, C is the distance from the focus to the center of the ellipse. And we have this nifty equation for ellipses in which you read that c squared equals a squared minus b squared. So substituting this 3 for a and this 2 for b, we get c squared equals 9 minus 4. C squared equals 5. So c equals plus or minus radical 5. And we know that the focus is along the major axis. So if we're going along the major axis, we're going to go up above 3, -1, and we're going to go down below 3, -1. Well, that affects my y values. And that's how I got 3, comma, -1 plus or minus radical 5. Whew, well, that was pretty good. Let's see how you do with a problem similar to this. So problem number 2 looks like this. Oh, look at that. Uh-huh. That is not written in the form that's very useful to us. Now notice when we have ellipses, we want x squared plus y squared. This needs to be a 1. So I've got to do a little bit of work. Let me make this a 1 by dividing both sides by 200. And that gives me x plus 5 over 25 plus y squared over 8 equals 1. Now notice I didn't have to complete the square. It was already done over here, and there's no linear term for the y. So I can start filling in my goods. Now why don't you pause the video and see how you do. Can you find the center first? Can you find the vertices, the length of the major axis, the length of the minor axis, and the coordinates of the foci? Hey, welcome back. I got my center to be -5, 0. By the way, I knew this was a horizontal ellipse because the bigger number was under the x. I know that this distance here is a, and I know a, by the way, let me get a pen. I know that a is, spinning circle. I know a is 5. Oops, whoops. You know what? Actually, I don't need to do all this. I have this thing handled right here. I know a is 5, and I know b is 2 radical 2. And so I can go in and say, well, the major axis is clearly 10 units long. The minor axis is clearly 4 radical 2 units long. And to find the foci, I'm going to use this nifty little equation. C squared equals a squared minus b squared. And I got c is plus or minus radical 17. And let's not forget, c is along the major axis. And so that's going to go and affect my x's. All right, why don't you go ahead and tune in to part 2 of this video next?